Hello, I'm Ujin Chan. Our presentation about my Arduino project. My project was to create a study helper that helps users study. It counts the time for the users to study for 45 minutes and informs the rest time after 45 minutes and set an alarm using the red LED to study when the break time passes 10 minutes. It was also planned to use ultrasonic sensor to detect if the user is studying or sleeping and help wake him up. This is my schematic. I draw my schematic through the freezing tools. From now on, I will explain my timer development history. Firstly, I started looking for what Arduino program was needed for the timer to work, and Professor Tim recommended the TM1637, which can measure real time. I wanted to add and subtract 45 minutes in this real time measurement program. But from the beginning, there was a problem. TM1637 did not compile properly on Arduino. I've been trying with this over and over again, but I've only found that it doesn't work properly on my laptop. So I finally gave up on real time and looked for another time source. I found a timer source called Simple Timer that used the Arduino's own timer. I used a simple timer library and connected the button and alarm and LED. And I put variable called pstate to represent the current state. The initial value is set to low, and I set the Boolean value variable representing true or false as a variable related to the timer. This Boolean variable can only have one of two values, like a true or false. That is, it checked whether the timer is scheduled or not. Buttons are input and LED are output. That is, when the button is pressed, the value of pin 2 is read and the value is checked in the state. If the global variable value p state is low and the current state is high, that is when the button is pressed, the booked value is changed from the false to true and the LED is turned on. And a function called setTimerOut is executed. Okay, I will explain about the global variables. Global variables can be used in all function, can be declared outside of functions, and if there is no initial value, 0 is assigned as the initial value. However, local variable can only be used within functions and can be declared within functions. If there is no initial value, the value of garbage is put into the variable. The first thing in this function is time, and 5000 means 5 seconds. The second thing is to call the beep function. This means that the buzzer sounds. But the timer doesn't work just because I've written so far. The actual timer that runs is timer run statement. The beep function turns off the LED while changing the booked value. That means stopping the timer. And the frequency of wave and duration of the sounds are adjusted through a function called tone. If I had to choose the most important command in this timer, it would be timer set timeout. This is a command that calls a specific action to be executed after a specific time. After making this timer, according to Professor Tim's advice, I wanted to make a timer control using a potentiometer. I made a potentiometer and applied some basic grammar, but I couldn't make a time control with it. Next, I will explain how to measure distance with ultrasonic sensor that I wanted to implement. Ultrasonic sensor use trigger pin as output and echo pin is the input. The principle of this sensor is to fire an ultrasonic wave from the trigger pin and wait for that ultrasonic wave to come back. If it hits a wall, an obstacle, and returns to echo pin, the ultrasonic module transmits one PWM signal to Arduino board through the echo pin. This PWM signal means the round trip by the ultrasonic wave, and the time is stored in duration. I implemented an ultrasonic sensor, but I had a lot of trouble putting this and a timer source together. However, I managed to divide the setting value and the loop and eventually succeed in making into a one source code. The last difficult thing I did was to make the combined source code together organically. I used a do-while loop and made them move together, but I ran into one problem here. It was supposed to activate the ultrasounds as the next step when the button was pressed. But in the do-while loop I wrote, the do loop was activated immediately, so it could not exit the loop and only displayed the result of ultrasound. I tried to use for loop, but I'm having trouble this for loop also. So, unfortunately, I couldn't get the ultrasonic sensor and timer to work together. Additionally, I use looking for showing the timer time through the 4-digit 7-segment display. I bought $5 adapter on Amazon and tried to get it to work, but this is basically couldn't be implemented with the default source simple timer I use. This was impossible with the TM1637, so I couldn't work anymore. As a result, when the button is pressed, the LED turns on and the piezo buzzer sounds 5 seconds later. And I implemented an ultrasonic sensor and potentiometer together, but I couldn't make it work with the timer. However, through this, I implemented the code by myself and my understanding of electronics was greatly improved. And my understanding of computer source code also developed. I would like to thank Professor Tim for advising this project. Also, I would like to take this opportunity to say thank you to my classmates who have studied the heavy-duty program together for the past 2 years. Thank you so much for helping whenever there was a difficult lab. Thank you. I always support you whenever you work. Thank you very much.